Hello, welcome to today's session. In today's session, we are going to learn more about the transactions and which will also introduce us to the concept of blocks. So today we are going to discuss P2PKH, which is pay to public key hash. Right. So let me share my screen and we are going to just revise a few of our concepts that we have discussed previously. Right. So let me know when my screen is visible. Great. So is my screen visible now? Yeah, if it is visible, type B in the chat box. Thanks, Prashant. Great. So if you remember in our previous sessions, we have revised how transactions happen. We've also seen more in detail about all the other modes and transaction inputs and outputs, which was Hackathon 5 or module 5. So let me just give a quick recap. So people who have joined us recently, not worry. So how this works is all the revision hackathons are a revision of the actual lecture done by the primary faculty. Here in our case, it is Professor Pandurangan. Right. So we are going to revise a few concepts. So Praveen sir says, this is your first session. So let me first show you how this works. Right. So if my screen is visible, so let me know. Great. So if you open up your Teachable, this is how Teachable is going to be visible for you, right? In that, we are going to cover the module 5. So because you joined recently, you would not have a clear idea of the module 1 to 4, which is apparent because you've recently joined. So no worries there. So what I would suggest is you can start from the beginning if you have done the orientation and start from the beginning of it. And all these revision hackathons in a cyclic manner. For example, this one batch of revision hackathon is happening and we will go from 1 till 10 and little of solidity again from 1 to 10, right? So these hackathons keep on happening. So first I would encourage you to go to the first session, which will be this, and you can go ahead and watch it. It will be clear on how to go forward and all those things. So there is also, because this is the actual course, the course name in your Teachable will be IIT Madras CC and Pixel Test Blockchain, right? Similarly, in your 4 courses that you received, that you will have the inner circle. So in the inner circle, towards the end, even the current session, like for example, we are doing a hackathon of module 5, the second portion, even the recording of this will be made available in that, right? So what you can do is you can go through the actual lecture and then also go through the revision lecture. So you can choose to just go through the actual lectures or go through actual and revision so that your recall of the concepts becomes stronger, right? So we are here. If there's anything that you require, you can get in touch with us. I have shared the contact here if there is anything. Yes, Praveen sir. So I would request to go to Teachable, right? Because these are unlisted videos. This will only be available for your email, right? So you can always go ahead and watch it from your Teachable itself, right? So that should be there. Yeah, thank you so much. So yeah, you can just go ahead and save it. So that is an instruction for all the people who have joined recently, right? So that should not be a problem. You can choose to continue through the session, or you can drop and begin from the start, right? So that's also possible, right? So in our previous sessions, module 5, we have discussed about transaction inputs and outputs, how the structure of input is there. We've understood the locking script, we've understood the unlocking script, right? So yes, Praveen sir, you can continue, right? So I'll keep it beginner friendly also. So in 1 to 5, so what we have done is we have navigated from why the need for blockchain was there. And then we have understood a few systems of hashing, right? Which is encryption. Once you go through detail of it, it will be easier. Then in our next module, we have understood how to use, I know how wallet addresses are generated, what is the concept behind it, right? So we have understood that in module 4. In module 5, we are understanding something called the transactions. Like whenever one person sends money or Bitcoin to other person, it will have a structure. The transaction will have a few inputs and outputs. We've discussed about that, and today we are going to discuss a few challenges of what we understood in the previous session and how to overcome that, right? So if it is overwhelming, you can always go, how to proceed forward. It should not be a problem, right? So yeah, thank you so much. Now we have understood transaction verification. We've understood about this language that Bitcoin has, which is called the script language, where we have seen the stack of it, right? So if you remember the stack, we have understood the stack, right? So let me bring up the image of the stack. Becomes easier for everyone. Yeah, so let me share my current screen, right? Okay, so you see this, we've understood a little about stack, where the data and the operation both are pushed onto something called stack, right? So people who have joined recently, you can go through the session to understand it deeper, either the actual session or the revision session, right? So you understood how step by step each of the operation is added onto the stack and executed, and how we have a full-fledged verification process that happens, right? So we've also checked this verification. Here it is more of data and operations, but in our previous sessions we've understood the logic behind it, which was the elliptic curve and all those things, right? So I hope that was clear. If this was all clear for the people who have joined previously, type C. Thanks, Prem. Thanks, Vijay. Thanks for Lakshmi. Okay, great. So people who are watching us on our social channels, you can, we are able to see all the, comments in chat. So you can go ahead and use the chat and comments in the respective social channel. If you are watching from LinkedIn, YouTube, any other channel. And we've also revised a few concepts of a session, the session before that, right? So now let's, right? Okay, let me bring up the slide. Yeah. So if you see, after transactions, even in module 5, the second half of it, why I'm saying this particular session will be smaller, because in a previous session, we have discussed most of the transaction structure, the inputs, the outputs, stack operations, and how they are executed and how the verification process happens, right? If we have seen in our previous sessions that you send Bitcoin to the the public key hash or the wallet address of the other person, and now we'll see what happens, what are some disadvantages of that system, right? So now if you see pay to public key hash, so we have seen this is what the system that we have seen. You are going to pay to the public key hash of a person. For example, Tom is sending something to Alice, he'll be sending to the public key hash, because if you remember the operations, the OP, DUP, and all those things, in that the 20 byte public key hash is always there, right? So in a way, you're paying to the public key hash. right? So we have seen a few good things about that, where you're able to embed all of the code that is happening in a transaction, right? We have seen that. What are a few inherent problems that are coming with this is, for example, if you want to send some Bitcoin, let's say 0.05 Bitcoin to someone, right? And okay, so people who have joined right now, you can go ahead and mute. That will be helpful, right? Okay, great. Thank you so much. Now, what we are going to do is we are understanding the inherent problem. Thank you so much. So now A is transferring to B, right? And let's just say B is no more, right? For example, A has transferred 0.05 Bitcoin to someone, and now B is either maybe he expired, or maybe he, he's no more able to access it. The challenge is the money that was sent to that particular wallet is lost forever, right? So because the nature of all of the transactions, because the immutability, so the people who have joined recently, immutability is where you'll not be able to modify anything in the blockchain, right? So because everything is one way, if you have sent it also, it is one way. So if the person is no more, your money is lost, right? So if you've understood this, type U in the chat box. Okay. Thanks, Vijay. Thanks, Kumar sir. Great. So now this is one challenge. Now money is lost, and we know that Bitcoin is limited. So why is Bitcoin limited? That is how the decentralized system came into existence, right? So if at all you are able to create as much as Bitcoin forever, there'll be inflation, deflation, and it will be as similar as the current currency system, right? So Bitcoin is limited, and if you see this, money is being lost, like to many people. Like for example, somebody lost their key hash, their secret key, right? Somebody misplaced or it is compromised. If somebody has got the key, they'll be able to steal the Bitcoin, right? So these are all these problems are there, and whatever money is lost, it's lost because everything is one way. So how do we face this particular challenge, right? So why Bitcoin was limited? Because to control the inflation, deflation, that is how this is limited. But when it is limited, losing money is like what happens is, in a regular system, if for example there's a ship going, and an example taken by Professor Pandurangan sir, there was cash in that, and that let's just the ship sank. Okay, the money is lost. Similarly, like here in Bitcoin, the money is lost for, like nobody can go ahead and find it. And but in regular system, there could be more currency that could be printed, like and though the value will be lesser, currency could be printed. But in Bitcoin, if it is lost, it's lost. Now the key might be stolen. This is an example that we have understood. The money could be lost. And for example, if there is a manager, like let's just say Professor Pandurangan says, if you are the manager yourself, and let's say there's some intent comes in, and you run away with it. And as an example, a fun example that Professor explains is, right? What happens then? Because it's still one way. You were managing the organization's, let's say, account fund or something via the Bitcoin address or the wallet, and and not able to be, you're not being able to reached out, right? So that's also a problem. So these are all a few limitations that come when you're working with sending money to a public key hash of one person, right? Because the system is immutable, you'll not be back to, you make edits into that, whatever sent is sent, right? So if you've understood the limitations of sending money to a public key hash, if that is clear, type C in the chat box. Thanks, Vijay. Thanks, Prashant. So we have people who have joined recently. Do not worry. You can go ahead. Thank you, Raja sir. So you can go ahead and watch from the beginning. If there's any example, you can mention you joined recently. you can put it in the chat box. If there's any help beginning of this session in Teachable, you can start from the beginning because these are revisions of the same sessions, right? You can start from, if at all you want to go through the inner circle, the revision only. So basically only the inner, revision only. You can go into the inner circle vault. Towards the end, you will even found the. Okay. Suraj sir says nothing is audible. Suraj sir, did you? I would request you to disconnect and join. Maybe your audio.
Hello?
Yeah. Okay. Yeah, Suraj sir, we are able to hear you.
No, Sachin, nothing is audible. Is my voice audible?
Yes, yes. Right. So let me put it on chat for Suraj sir. Disconnect and join audio. So I think that should help, right? So everybody else, if it is audible, type A in the chat box because I've been speaking. Okay, Suraj sir says, okay, done. I hope it is audible now, sir. If it is audible, Suraj sir, yeah. Okay, thank you, Vishal. Thanks. Okay, right. Thanks everyone for letting me know that is you understood this. So this was something that we've understood. The pay to public key hash, we've understood that. Now, let's go ahead and understand the other concepts, which is multi-signature, right? So when you, for example, you are an organization, you see that all documents are verified when at least two or more directors sign. So, or it's a joint account, right? So a similar analogy will come into the multiple signature concept, right? So let me just wait for so Suraj sir, is it audible now?
Yeah, now it's fully audible. Thanks.
Yeah, okay. So sorry. So basically, Suraj sir, maybe you might want to go through the restream link that is there in the email because you might have not heard the audio in the beginning sessions where we discussed about the challenges of public, sending money to one particular public key hash, right? So now we are discussing the multi-signature. It's like, when you have a joint account with someone, the transaction, for example, in the account, you have 4 people, you can always mandate saying any 2 people, if they sign, or any 3 people they sign, then the documents will be accepted, right? The check will be passed. So such similar analogy is there here in blockchain also. When you're sending to one person, if he is, his intentions have changed, or if the person is no more, the money sent is lost. Now, what happens with multi-signature is you can, you in this scripting key only, you can have public key hash, like the key always say. So several stakeholders have to take a decision. Now there is a way which says M out of N signature. Remember this means like 2 out of 3 signature scheme, right? So out of 3 people who are there, the stakeholders, 2 people's signature has to be there. Then only you will be able to receive the Bitcoin, right? So we'll see this in action here. So now you see earlier it was only one signature. Now you will have signature A, signature B, and signature C. In our example, 2 of 3, if you are looking at, these are the signatures, and I know how it is collectively a public key is generated. Like how you have a current account or a joint account, the account ID is always same, right? The account number is same, but behind the operation, it is coming collectively to all the people, and two or more people or 3 or more people, based upon whatever agreement you had while creating that account, you will be able to withdraw the amount, right? So the check will only pass if there are 2 signatures. Similarly, right? So if this N signature scheme got clarified, if you are clear of this concept, if you understood this briefly, type U in the chat box. Thanks, Sushil. Yeah, so people who are watching us on social channels, you can use the chat section also. Thank you, Radha sir. Okay, so now this has been simple. Thank you, Suraj sir. Great. So now how does this happen? So now when you have unlocking script in our pay to public key hash, right? When you're paying to public key hash, there was unlocking script only public key hash of one person out of 3 signature, 2 out 10 signature scheme. 2 signatures, right? So we'll have signatures of multiple peoples. So whenever you are checking, when the script language of Bitcoin is checking, it will check, okay, I think I found either A or B or B or C or A or C's signatures in this. Now, because the signatures are there, meaning this transaction was signed by 2 people who are part of this 3 signatures that I have to verify. Okay, now this seems like a legit, collective public key. Let me go ahead and verify this transaction or send this Bitcoin, right? So this is how the multi-signature works. So the actual format of unlocking script will be now how we have signature of person. So whenever you have a joint signature, for example, if I have Jay Ganesh, Irfan, or Raja sir, the 3 of you have signatures, your signature unlocking script format will be first signature of Jay Ganesh sir, then Arif sir, then Raja sir. So you'll have all of these, and before that there'll be a 0. So it's like a numerical representation. So each of your signature, just before that there'll be 0 prepended to that, right? So this is how the multi-signature works. Let us go ahead and see how Sir has explained this here, right? So now we've understood there will be multiple signatures when you're trying to verify. Let's try to understand signature verification here. So now the look of the stack operations will be like this, right? So let me go back and people who have joined recently, show you like how the signature format was there previously, right? Okay. Yeah. So these are screenshots of what professor explains in the sessions. So in our previous sessions, you see when you're sending it to one person, it is DUP OP hash, and yeah. Okay, so let me just check my Wi-Fi is proper. Yeah, great. Okay, so Vishal says my audio is cracking. If somebody else also faces a similar issue, let me know. If my audio is clear, type A in the chat box. Okay, now Suraj says it's clear. So maybe I request Vishal sir, maybe you can check if there's the internet issue or the Bluetooth battery being low issue or something, if you are on Bluetooth or something, right? So in our previous sessions, we have seen the signatures have this particular format. But now when you're trying to verify multiple signatures, right? Earlier, let me just go ahead and show the example live we have seen. So this is the live example. Don't be overwhelmed if the first time you are seeing this, right? We have explained this in our previous sessions. Okay. Thank you so much, sir. Yeah. So now let me show you. Yeah. So now if you see there is OP check sig in our pay to public key hash kind of a system. So this is how people have joined recently. In our previous sessions, we have explained each of these operations. So this is a previous layout of the commands. But now what we are doing is the command here will be check multi right? We explain what each OPDUP means duplicate the item, right? OP verify equal means if the inputs are exactly equal, it will return 1. So everything has a meaning, everything has an operation definition, right? Similarly, when it is operation check multi-signature, so there is an explanation given out here. What it does is it goes ahead and checks if like if it is 2 out of 3, right? So now what is mentioned here, 2 out of 3 check multisig. What it will check is out of all of these, check if 2 of them are available in the output, right? So when you check that, it will be verified, right? So this is what this particular thing means. We'll see this in detail, right? Check multisig operation here, right? And the 2 here and 3 here mean M and N. So 2 out of 3 have to be valid in that particular thing, right? So this is verification of the signature. So if A's key is compromised, for example, A has key that got revealed to some person who's tap wiring or trying to understand what is happening in the transaction. And now because it's only one person, you will not be able to, the person, the hacker will not be able to get the amount because he only has one. He is not having the other person's key, right? So even the money is not lost. Like for example, if A is no more, B and C can still access. The money is not lost. So because the money is scarce and limited, there is still a way to access the money because B and C are still available or alive in this example, right? So what is the upper limit of N? Like how many signatures total, like, how the body, when it was introduced, the N was 15, like meaning you can have 15 signatures altogether and you can multi sign check, like let's say 2 out of 15, 3 out of 15. So 15 is the max, like, if at all you wanted to have a joint account, say like that analogy, you don't have a joint account here, you have a multi-signature verification process, right? So now what do we call this system, right? So now let me explain. So earlier we were calling it pay to public key hash. Now we are going to call it pay to script, right? Because what is happening, because it's a multiple signatures, right? You're not sending it to one signature. So you're going to send it to the whole script of this particular collective public key hash, right? So let me show you this. Even professor explains this on the what you call the resource that we have, the actual book, which is I'll be sharing the link for the same, which is the Mastering Bitcoin by O'Reilly. Okay, so in that I'm going to the page that professor explains, which is 155. Okay, so I'm going to go ahead and show the same here. Now what is happening is we have this example, right? First, pay to public key hash, we have understood everything here. Now the pay to script hash, P2SH. Script hash will have multiple signatures, right? Yes, Suraj sir. Yeah, so those are the hackathons are in inner circle. If today's recent one will also be uploaded, right? I'll be able to share the details. Okay, over to you. Great. Okay, so if my voice is breaking, so let me double check. I think the voice should be better than before now, because maybe I've just moved in closer to the network. So let me know if there is still a challenge, right? Thank you so much, Kumar sir. Now we've understood the difference. First one was public pay to public key hash, one person, pay to script hash. Script hash is a combination of all of the signatures, right? So this is the second concept. If you have understood what we call this new multi-signature, kind of transaction, which is pay to script hash. If you understood this, type U in the chat box. We'll see an example of the same. Thanks, Lakshman. Thanks, Lakshmi. Thank you, Prashant. Okay, we'll move forward. So now we'll see an example, right? So the resulting output, the script will look like this, right? Let's say 2 out of 5 we are doing, right? So we have seen our structure, right? We had it like this. 2 out of 3 check multisig here. Now, if you look at in the reference, I hope my PDF is visible. If it is visible, type V in the chat box. Okay, so the link for the same, I'm sharing it here on the chat, right? So you can go ahead and access it. Thank you, Vishal. Thank you, Suraj. So I'm on the 153 page right now. You can also go through it. This is what professor also shares. The resource is also available on the lecture, so you can go through it, no problem. Now it is 2 out of 5. So what is going to happen? First, let's just say the one primary person is Mohammad's public key, and then his partner, other 4 partners are 3 partners are there. And then let's say there's another attorney public key. Let's say there's another verifier or the attorney we are going to have. So any 2 out of these are there, the operation check multi-sig will check and revert that, okay, because 2 people are there who have signed this. I think I'm going to verify this transaction, right? So now what is happening is it will look a little complex because now 5 people's scripts will look like this. So previously it is going to look like 2, 5 and public key 1, 2, 3, 4, 5 and operation check multi-signature. The unlocking script should have at least 2 signatures. Now locking script has 5 peoples, right? So 5 people, because this is the these are the 5 people. Out of this, any 2 can be, if they are there, you can unlock the transaction. So the unlocking script will have 2, right? This is now this complex script. Now what we can do here is, instead of trying to show it every time this big locking script, we can try to simplify it by hashing it. So people who have just recently joined, in our module 2, we have discussed how to make a big byte stream or bigger message into a fixed length string, which is called hashing, where you make it small compressed, right? So here also what we do is, instead of having this 5 people key, we are going to use hash of that particular whole of the 5 people signatures, right? Which makes it easy. So let me give you an example, right? So now if you see 2 out of 5, and if you're going to add public key hash of everyone, like the first person, Muhammad, second partner, third partner, fourth partner, and the attorney, right? So like, I'm sorry, I'm just giving you an example, like they are here, right? It'll look very complex, right? So it's going to look like this. And trying to do this manually or send it to some person is very challenging, right? So how do we simplify it? We are going to use hash. In our sessions, we have multiple times used hashing to make things simpler. So we are going to hash it. So when you hash it, this will be the output, 20 byte single thing, and you can just go ahead and use this like you were using in the public key hash, right? So when you're sending it individually to a person, there is one public key hash. Now something similar you can do, but this will be a hash of all the 5 or more signatures, right? So it is like a compressed version, right? So which makes it simpler. Now, how it is going to look is this way. So the locking script, it will be simple. 2 out of 5 is like this, and the hashing will be there of the all of the scripts, right? So it becomes simpler. So if you've understood how this script is being compressed by using hash 160 or hash 256, if you understood that, type U in the chat box, right? So the people who have joined recently, let me just go ahead and show that. Okay, so these are all resources that we have shared previously. Let's just say there is a bigger text. Okay, this is just example. I just said this is the 5 people's script. I'm going to give you a bigger. Yeah, so SHA-256, it is hash 160, right? So it is kind of the double hash we have done before. So I'm just giving an example. This is random I have entered. Let's assume this is the 5 people's public key, and when you encrypt it, when you hash it, this is how it looks, right? So but here we are not using SHA-256. What we are using here is you can see hash 160, right? So now hash 160 is here, right? So let's say I'm giving the encode string this way. Now you're going to get a single hash, right? So this is how this is going to work, right? So people who have not understood like how to hash this currently, do not worry. Right now, this is a tool. It's like a calculator, right? So you input something, there's an output, right? Right. So now if you see, there's a smaller change also done in this particular output. Let's say I'm just saying change made. Okay, I'm just making. You can see there will be the hash will change. It will completely change, right? So for every unique input, the hash will be in unique, right? So the logic of it, everything has been discussed previously. So do not worry. You just need to understand at this moment that if at all there's a complex string or multiple people's keys, you can create a single key by using the hash 160, right? So if you understood this portion, type U in the chat box. Great, nice. So thank you, Raja sir. So many people have understood. So now this is called the public pay to script hash. Earlier you were doing pay to public key hash of a person. Now you are going to pay to script hash. If you're thinking in analogy, right? You're not going to pay to a single person's account. You're going to pay to a joint account, right? So that's how it is. Now there are benefits to it. What are the benefits, right? So you might be able to already understand what are the benefits, but let me just explicitly tell about it, right? Okay, so these are a few inputs, a few screenshots from Professor Bandurangan sir's session to make okay, so earlier what used to happen is okay, we are starting from here below. So this is how the public pay to public key hash was there. There's a signature input. In the input there's a signature and public key, and towards the output there was one person's public key hash. Now what we are going to do is we are going to remove the hash of public key, and we are going to use the script hash here. We are going to use the hash of script, right? And we are going to, instead of sending the public key here, we are going to send the script directly, right? So this will be the final thing. So there'll be a signature, multiple signatures will be there. Instead of sending it to one person, you're going to send it to script, right? So this is what sir explains, professor explains in detailed also, right? You can even go through that, right? So this is how it works. So now let's go to advantages. So what are the advantages? Now, for people who remember, the transaction blocks would be this way, right? So every transaction, whenever a miner is uploading transactions into a block, what he's doing, he's going to charge you a fees, right? Now, if your transaction is bigger, you're going to get charged a little higher, right? So you have to you're making his life easier by sending a hash, a shorter transaction byte, and your transaction is shorter, and you're being charged a little lesser transaction fee. Like, let's just say if all of your transactions are shorter, you're going to save a lot of the fees that you're going to pay to the miner, right? So if you understood this advantage, type U in the chat box. Yes. Thanks, Prashant. Thanks, Vijay. Thanks, Rajesh. Right. So this is how we have understood the first transaction. Now, even when you're paying, you can specify to whom. By sending, you do not have to say send to this key, this 5 people or 2 people's key. You can just give him the script, right? You can say, please send it to this script, right? You need not have to tell, these are 5 of us and you can send it to 2 of them. You don't have to, you'll not do that. Like, you don't have to specify individual public key hash. You can just say, send it to this particular script. It becomes easier. You can just specify to, send it to this particular script. You don't have to, write all of it all together, right? The fees you pay becomes lesser. The transaction will take lesser storage on the block, right? So this is what we have understood here, right? So these are a few advantages, and okay. So these are a few points from our previous lecture. So these are if you understand, this is all about public pay to script hash, right? So if you understood the pay to script hash, this would bring us to the conclusion of today's session, because as I've mentioned, this particular session will be shorter because this ends the module 5, right? The revision of the module 5, because the half of the module 5 we have discussed in our previous hackathon, right? So now you understood pay to public key hash and pay to script, right? So if you understood both, type U in the chat box. So people who have joined us recently, if you understood briefly, like overview of what happened, you can still type U, because now once you go back, all dots will connect, right? So if you understood all of this, type U in the chat box. Thank you so much, Praveen. Right? Thank you, Raja. Great. So what I would request is you can go ahead and continue in our next session. So what are we going to learn is about blocks. Even Professor Bandurangan sir explains the blocks. Let me just give you an overview of what we're going to learn, right? So now what happens is this will be more on the miner side. Now we have understood inputs, outputs, one person trying to send to other person, one person trying to send multiple people using the multiple signature. I understood all this. Now we'll understand how the money is getting created. What is the mining process altogether in the sessions that we go forward, and we'll understand something called coin-based transaction. So in our next session, whenever a new block gets created, there is a block reward that is taken by the miner. So what is creation of a new block? For example, there are multiple transactions happening on the network. A person verifies all of these, or a node or a system verifies all of these, and verifies. Once it is verified, it uploads onto the block, right? One block, and this one block will have 1 MB. So you can have like 2000 transactions or more based upon the size of each transaction into each block, right? So whenever you create, you upload this is the transaction verification method. And if at all, for example, you go ahead and do upload all of this, you will get a block reward. Now, when you create a new block, now we have seen transactions being uploaded and verification. Now a new Bitcoin block is created. Yes, Praveen sir, you're right. So new Bitcoin is created, and apart from the transaction fees that the miner gets, he'll get a little bit new Bitcoin that is getting generated, right? It's not just the transaction fees that he's getting. If he's creating a new block, he's also getting new Bitcoin money. It is not being sent by any input to this person, to the miner. So he's generating it. So more about this we'll understand in our next session, and that is where we'll so this particular type of transaction is called coin-based transaction, where the verification is happening and also block is getting created because there's no input. The system has a way to reward this particular person for creating new money, and that particular reward this person is getting is the the Bitcoin for himself, and that enters the system. Now he can send it to a merchant because it's the effort that he has put. He has earned all of this, right? So now new money got created using via the miner. He can choose to hold it. He can choose it to make transactions, right? So that is a little bit of coin-based transaction. So if you understood the overview of the coin-based transaction, type U in the chat box. We'll see more of it in the upcoming session. Yes, thank you so much, Raja sir. Okay, thank you, Vijay, thank you, Prashant. So Praveen sir, yeah, so you'll be able to find them. Okay, thank you, Subrata. So you can find them in the inner circle towards the end, right? So I'll share where you can find to you, Praveen sir. I hope you have saved the contact. Right, great. Yeah, so Praveen sir says ask reply. So please, okay. So did I miss? So I think I've answered your question. Let me share it once again. Okay. Could be, sir, could be. So I was doing also delivering, right? So yeah, you're right. Okay, so this brings us to the conclusion of the session. Thank you so much, everyone. I hope this was valuable. If you want to revise it, you can go to the actual lecture, module 5, the first lecture. This is the second half of that particular lecture. Great. If Subrata sir asks if I complete module 10, yes, Subrata sir, you can go ahead and if you finish the module 10, you can take the NSEM quiz and get the certification. Great. I hope that answers your question. Thank you. Thank you so much. Thanks, everyone. And if there's anything, any query that you're getting, even if you're starting from the beginning of it, if you have any query, for example, you have stuck in module 2 or 3, and there's any query, please bring this up in the next session. In the Q&A, we're going to answer those, right? So do not worry. Go through it. It's made simple. And if at all you face any challenge, bring it to Tuesdays and Thursdays, 4 p.m. Yeah, so Vishal sir, because you also joined recently, you can choose to attend these to get an overview. But I would suggest you to recommend you to go through from the beginning. So then it'll be, the recall will be really stronger. Yeah. So Praveen sir, did you mean TOC or table contents? So you can go through the teachable list itself is the table of contents. Point of contact. Yeah. So this is how you can always reach out to me, Praveen sir. Right. So every Tuesday and Thursday we are doing it. Yeah. So and you even have the contact, right? So you can always reach out. Great. Okay. So thank you, everyone, and have a great rest of the day. And we'll see each other in our upcoming blockchain hackathon. Thanks, everyone. So people who are watching us on the social channels, not joining the Zoom, please go ahead and leave your inputs and feedback in the comment section or the chat section. Yes, thanks, everyone. Have a great one. Bye-bye.